Welcome back to Cloud 42, I'm James. Today we're continuing work on the Toolpost grinder. This is going to be part 5. If you haven't seen the other parts of the video, there's a link down in the description. You can go check those out. Today we are going to work on the spacers. And just to change things up a little bit, let's go over to the computer and take a look at the parts there. Here we are in Fusion 360, and this is the Toolpost grinder design. The parts that we're going to work on today are these spacers. There's one here in the front, and there's another one just like it here in the back. I'm showing them out of brass in the drawing here because I thought that would look nice. I'll have to get out in the shop and see what kind of material I actually have. Now, the purpose of the spacer is to carry thrust loads through to the inner bearing race, which otherwise would be hard to reach because of the screw-in bearing caps. Now in the back, the Belleville disc spring is providing a preload force that's carried by that spacer through to the inner bearing race. And in the front, the core of the spindle, the collet holder, has a shoulder that bears against the spacer and carries the axial load through to the inner bearing race. Now, these are not difficult parts to make. They're cylindrical. The only thing is that the tolerances are pretty close. It needs to fit tightly on the spindle, but still have enough room to slide freely. So it needs to not move around, especially because there's only about 1/4 millimeter of clearance between the spacer and the bearing cap. And so if it moves around, it'll make contact. So it needs to be tight there, but it can't be too tight. It can't be a press fit. It has to slide freely because you've got the spring force here in the back, providing the preload through to the inner bearing race. So this needs to be able to move freely so that the preload force remains constant. I think I'm probably going to do this in the 3-jaw chuck because I have a backing plate for it that'll make it easier to face these off evenly to length. But before I switch the chuck, I'm going to take care of one other thing. You'll see there's a register shown here on the back end of the spindle, and the purpose of that register is just to give the drawbar something to center on. The diameter doesn't matter at all, but it needs to be concentric, and the core of the spindle is not concentric from the factory. It was just drilled. So I think we'll chuck this up first and go ahead and bore this register, and then we'll put the 3-jaw chuck in and get to work on the spacers. Okay, so there's no particular diameter that's required for the register in the back of this, but it does need to be concentric. So let's go ahead and dial it in here in the 4-jaw. Oh yeah, not even close. Okay, that's at least snug. That's not terrible. Let me pull the belt off to make this easier. Let me grab a dial indicator. Okay, that's pretty cool. 10 thousandths, just on the initial checking. Okay, let's see, that's the high spot. Let's tighten that just a little. Loosen the low slightly. Tighten the high a little. Okay, we're getting close, but I don't think all the other jaws here are tight. Let's make sure they're all tight. Oh yeah, they weren't. Not even close. Okay, that's the low. Loosen that slightly. That's still the high. Tighten it a little bit. Tighten the high. Now that's the high. Okay, very close. Okay, that's less than half a thou, perhaps a lot less. It's about a quarter thou actually. That will be just fine. Okay, let me re-engage the belt. And I think we're going to run this at, let's do it relatively slow. Let's go 720 RPM. Should be able to go a lot faster than this, but this stuff's hard, and so I'm going to take it conservative. See what that looks like. Yeah, I think that'll help. I don't know if you can see that the bore that is running out slightly. Let me grab a boring bar. This is a 10mm carbide boring bar. It's a little bit smaller than the 12mm one we've used in the other videos, just so I can reach inside there. And let's just try to clean this up. And again, there's no particular diameter that's required. It just needs to clean up. See how we did there. Well, it doesn't look too bad. Stuff's pretty hard. Surface finish isn't great. I'm going to go ahead and bump the speed up. See if we can get a little bit better surface finish in there. In fact, I'm going to go way up. I'm going to go all the way up to 2400 RPM again, because the diameter of this is so small. This 4-jaw chuck is heavy, so it'll be interesting to see how this spins at that speed. Should be fine. Yeah, that got us a much better surface finish in there. That looks pretty nice. Now the drawbar is also going to bear on the end, so I'm going to take this opportunity to just clean up the end slightly and make sure it's square and clean. Yeah, that looks great. There's a little bit of a sharp edge on the inside there. I will knock that off. Let's see what we have to do to reach that. May have to raise this tool up a little bit. Yeah, I think so. Okay, that's that. Let's swap out the chuck. First thing I have to do is release the locks back here. This is a threaded spindle nose, and you don't want the, if you run it backwards, it's real easy to back the chuck off of the threaded spindle nose, and so there are these locks that are supposed to hold it in. I still try not to run it backwards, or at least try not to take heavy cuts if I have to run it backwards. Let's see, that's not a very good angle for me. Let me grab a block of wood. Go. And let's put the locks back in. Okay, we've got 3-jaw chuck in the lathe, and I'm going to make these spacers out of brass. I've got a piece handy. I think the color contrast will look nice. Now I've got to make 2 of these 1/4 of an inch thick. So I'll part them off a little more than 1/4, plus you got the width of the parting tool. So I'll have set the stock up here, stick out about 1 inch, and I'll plan on turning about 3/4 of it. Or 3/4 of an inch. Which should give us plenty. Okay, we're going to use high-speed steel on this, just because it gives a better finish on brass. So these are hand ground. This is a hand ground high-speed steel tool that I just touched up. And let's start by facing the end. We're at about 1200 RPM. Didn't quite clean up. Okay, that looks great. Now, I think I want to do the diameter, or do the inside first. So we got to get that exactly to size, and if we overshoot and it's loose, we'll have to make another one, so why don't we do that before we mess around with the outside of it. Grab a drill chuck here. Make sure the tailstock taper's clean. I always like to start with a spotting drill. Just try to make sure we're getting this started on center. Drills wander enough, and this helps. And next we'll drill something about 1/4 of an inch. It's actually a little over, but it doesn't matter. It's just a drill I grabbed. Next drill is a little over 1/2 inch, and we're ultimately going to 787. So this should be fine. Lovely sound until the drill gets centered and cutting. Okay, now there's some nice chips there. Okay, so I think we're going to use a high-speed steel boring bar on this as well. This is a Criterion style boring bar. Get this set up about square. It doesn't matter that much, but and I think I'm going to set up a dial indicator here as well. Find the bottom of the drilled hole so we don't overbore. Okay, set that up so the bottom of the hole is about 10 thousandths past the 0. Okay, let's just see about where we are. Again, we're headed for 787. And right now we're at about 485. So we got about 300 thousandths to go, which will be 150 on the dial here. Let's take 20 and see what that looks like. Okay, that was good. Let's take 30. See how that goes. We're taking a total of 50. Let's take another 30, which will bring us to 80. Another 30. Which will bring us to 110. Okay, let's measure and see where we are. See how smooth that bore is. Yeah, it's not the most amazing thing ever. .697. Let's start measuring with the telescoping gauge. Oh, and of course that one's not big enough, or too big. Not small enough. Okay, right at about 700. Yeah, about 3/10 over 700. And again, we're going to 787. So let's take 30 and then we'll take half of what's left and see if we can hit it exactly. Okay, we're big enough for the next size gauge. I measure that at 758.5. Let's try it again. time I got 759.5, but it was a little bit bigger bite. Probably scratched into the surface of the brass. No, that's twice in a row, 759.5. Okay, so if we're at 759, let's call it 760, and we're going to 787. It's 27 thousandths, which means we need to take 13. Now, I'm pretty sure at this level, since we're going to take a lot of tool pressure off, it's actually going to cut deeper. So instead of taking half of the 13, let's take 5 and just see where we end up. Almost 773. Let's call it 773. Actually, let me measure it twice. We're getting right to the point where it's easy to scrap apart. And it's about 772.6. So that means we've got 14 thousandths to go, divided by 2 means we need to take 7, maybe slightly over. I want to try to hit this about 1 thou over, or half a thou over. So let's take about 7.5. And this should hit us right where we want to be. Whoops. Telescoping gauge slipped. It's like right about 788, but that was a pretty stiff pull through there, so it's likely that it dented in a little bit and the real diameter is a little smaller. Let me grab a deburring tool here. And let's see how it fits. It's going. It's definitely tight though. Make sure I'm not riding up on a burr or a chip or something. that is so close. Okay, well, I'm gonna take a spring pass, but again, this boring bar is so springy that I'm gonna try to back it off at least 2/1000ths, just to make sure we're just barely scraping. Actually, I'm gonna back it off more than that and go until we just dust it on a pass. See how that worked? It just touched, just enough to raise a little dust. Oh, it's so close. Okay, I'm gonna dial in another 1/2 thou, take another light pass. That's pretty good. Fits, I don't really feel much in the way of motion. All the way out here at the end I can feel a little bit, but right up there at the bore, it's only the slightest little bit of play. That will be just fine. Okay, now let's turn the outside to diameter. Back to this tool, make sure I can reach everything I want to reach. That's probably about as close as I want to run to the chuck. And yeah, we're going to turn 3/4 of it. That should be plenty. Okay, let's just take a light pass and just make it round. Realize I never put a mark at the end here where I want to stop. Okay, on the outside, we're shooting for 945. Let's see where we are now. We're at 987, which means we need to take 42. Means we need to take 21. So let me take 10. Let me take 11. And that should leave us 10. 964.5. Which means we need to take about 10. Slightly less. This should be fine. Okay. This should be the last pass on the outside. Not crazy about that surface finish. What are we running here? Running 6 thou per revolution. Let's drop that back to 3 thousandths per rev. Oh yeah, surface finish is a lot better. And let's see where we ended up. $945 and 4/10. I can live with that. Okay. Let's put some light chamfers on the end of this. And we'll get busy parting it off. Okay, parting tool. Well, we definitely want to make sure this is square. Throw a 1, 2, 3 block over the jaw, and it's close but not square. You do this, you definitely want to make sure you're holding a little pressure with the tool against the chuck, and then make sure that the block is sitting on top of the jaw. Because if you have it out like this, as you tighten, you're pretty much guaranteed it's going to move a little bit and you'll drop the block. Okay. Now to part this off, we want to take, the finished part's 1/4 inch. And so we want to cut this just a little bit longer. That should be fine. There's an extra 32nd. Let me grab something to go in the tailstock to catch it. Just a piece of steel welding rod. Works great for this. Now I'm going to bring the speed way down. That will involve switching belts. Might as well take it all the way down. Not in a hurry here. This will be 150 RPM. Nice and simple. And then we need one more, same length. Okay. Actually, let me touch the edges of that first. Okay, that's 2 rings parted off. Okay, the next thing I need to do with these is I need to face them to length, and just putting something like this in the 3-jaw chuck and trying to get it square so that I get it face to length evenly all the way around is a very difficult thing to do. So I'm going to use a tool called a chuck spider, or a lathe spider. And all this is a 3/4 inch thick piece of aluminum tooling plate that's got 3 set screws in it and openings in it for the jaws. So I can just drop it in, and then this provides a parallel flat surface that I can register the part against. I'm not going to grip this too hard because it is a narrow ring. I don't want to push it too far out around. Make sure everything's tight. And we'll bring back the high-speed steel tool for facing. I'm going to bring back the dial indicator too. Okay, let's start by taking 5/1000ths off the face of that. Let me grab a depth mic and let's see where we are. Okay, we're looking for 1/4 inch. See, that's 250. 275, 80, 85, 288. And just as a sanity check, $291, yeah, so the 288 number is probably good. Okay, we're going from 288 to 250. So we need to take 38/1000ths. So what I'm going to do is I'm going to adjust the 0 on my dial indicator here. So 0, that's what we had, so we need to take 38. which would be right there. So now I'm going to set the dial indicator to 0 at that location. So that's what we're actually going to try to hit. Not going to take it all in one pass though. Okay, that should be exactly 1/4 of an inch. Let's bring back the depth mic and see where we are. We are about 4 or 5 tenths too small, and that will be just perfect. Let's put some chamfers on the edges. Okay, now, and let's see how close we got on that one. Let me blow the chips off of this. $249.5, $249.6, $249.5, $249.7, $249.7, $249.6.5, $249.5, $249.7. Okay, within 2 tenths. That's not bad for a little lathe like this. Well, we're making progress. These are the spacers complete. Let's put some of this together. It's a nice fit on the shaft. There's basically no play, and it sits nice and square against the shoulder. Let's grab the spindle. That's a nice fit as well. Very close clearance, about 1/2 millimeter, just like we planned in the drawings. Let's put one in the back. And that's exactly the same thing. Very nice. And this is the Belleville disc spring that'll fit on there. And then the pulley will compress that spring against the spacer, preloading the bearing. Well, that's it for today. Please give me a thumbs up if you like what you're seeing and comment below. Next time I think we're going to work on the spindle pulley so we can finally lock this whole thing together. Be sure to subscribe so you'll be notified when that happens. Thank you for watching.